Hello everyone, good afternoon. Welcome to my class. I'm Sir Cezar C. Cruz, or simply Sir Cezar or Sir Cruz. I'm a science teacher in Sacred Heart Academy, Bulacan, Incorporated. Are you excited for our discussion today? I hope so. Shall we start? To give you some ideas about what we are going to talk about today, first, let's watch this video, a short video. Okay, so while you are watching this video, will you please take down note? And you can also sing. Rushing in the mountain, shoulders high up the mountain. It's potential energy. Potential energy in motion is kinetic. Nothing is potential. Kinetic or potential. Tremor energy. Hey. Brain can release it. Kinetic energy. Kinetic. Exert also current and you hold it. It's potential energy. Potential. It's kinetic energy. Kinetic. Energy that gasoline is stored up. It's potential energy. In motion is kinetic. Energy that's waiting is potential. It's kinetic or potential. Energy. Hooray. Okay, that's it. Let's continue our discussion. Yes, you guessed it right. Our discussion will be all about work. But before that, let me lay out to you our lesson's objectives. So at the end of this lesson, you are expected to learn the following objectives. First, perform activities to demonstrate conservation of mechanical energy. Second, calculate work, mass, and gravity. Let us see later if these two objectives will be met in our discussion. We also have two essential questions. First, when do we do work? Second, other than people, who or what else can do work? So these questions will serve as guide in our discussion today. So keep them in mind. So based on video that you had watched earlier, I guess you already pictured out in your mind our topic for today. Okay, let's continue. Everything is energy. So before we proceed to our main topic for today, let's give some understanding about this phrase. According to Albert Einstein, everything is energy and that is there is to it. Match the frequency of reality you want, you can't help but get that reality. It can be no other way. This is not philosophy. This is physics and according to Albert Einstein. Truly, energy can be found anywhere, even as humans. Our body comprises matter and energy. So, to give another perception about this phrase, for me, when we say everything is energy, it's simply um, energy can be found anywhere. Energy can be found it's either into moving object or object at rest. Okay, let's continue. Mechanical work or simply work is defined as the product of force and displacement in the direction of the force and equation. So that is the simplest um that is a simple definition of mechanical work. Product of work of force rather and distance. A definition of terms or terminologies that we will encounter in our discussion today. Distance. It refers to the space between two objects. Force is described intuitively as a push or pull. Next, we have the gravity on Earth is a constant 9.8 meter per second squared. So later in our given problem, aside from the gravity on Earth, we will encounter also the gravity in other planets. Next, we have the weight is measured in kilogram meter per second squared or simply Newton. Next, we have the mass is measured in kilogram. Okay. So those words will be tackled in our discussion today. Okay. Describe what will happen if anything to mass and weight when you go to the moon. What would this happen? The moon or just chilling the space, your mass doesn't change, but your weight depends on the gravity force. You would weigh less in the moon than on Earth. In space, you would weigh almost nothing at all. Each gravity is as 6 times stronger as it on the moon. So based on the video that you had watched earlier, again, our topic for today is all about mechanical work. So when we say mechanical work, okay, mechanical divide into two, kinetic and potential. So when we say kinetic, it refers to energy in motion, and potential, it means energy at rest. Work refers to strength that you exert in performing any movements. It simply means mechanical work pertains to strength of an object to move. Okay, let's find work to know how to conserve mechanical work. So later, I will be giving you some examples on how, and I will demonstrate some examples of activities where you will see how to conserve mechanical energy. Okay, continue. Let's continue. Standard formula. So we have two formulas here. A, work equals to mass times gravity. B, we have the weight equals to force times distance. Okay, so these two formulas will be used in problem solving later. Okay, next. How to derive formula. Okay, so this is the simplest way of deriving formula. We are going to use triangular method for you to easy to derive a formula. W stands for weight, M stands for mass, G stands for gravity. Okay, this is the simplest way on how to derive formula. Okay, the horizontal line is for division, and the vertical line is for the multiplication. Simply what? If on the given problem, if weight is missing, our formula is simply weight equals to mass times gravity. And if mass is missing, our formula is mass equals to weight divided by gravity. And if gravity is missing, our formula is weight divided by mass. Simple as that. Okay. Next. So here are the steps on how to solve the problem. First, we have to analyze the problem. Second, write the given. Third, write the formula. Fourth, write the solution and answer. Okay. Example number 1. A science book has a mass of 2.2 kilogram. What is weight on the planet Mars? Okay. First, we have the given for mass 2.2 kilogram, and the given gravity on Mars is 9.8 meter per second squared, and weight is missing. So what is our formula now? Okay, next is get the formula. How? Simply weight equals to mass times gravity. Okay, how are we going to apply this formula into solution? Work is equals to, substitute the given for mass, which is 2.2 kilogram, and the given for gravity is 9.8 meter per second squared. Simply multiply the two given, and we will get the 21.56 kilogram meter per second squared, and that is the weight on the planet Mars when you are lifting or when you are holding about 2.2 kilogram of a book. Next example. What is the weight of a person if mass is 5,500 gram on the earth? As you observe, there's a given gram, but but based on our discussion earlier, the correct unit for mass that are we going to use is kilogram. So when you see gram or other unit, that is what you need to convert that into the right unit. Okay, how to derive or how to convert the unit. Okay, first we have the given mass equals to 5,500 grams. We have the gravity 9.8 meter per second squared. And the given problem, we are looking for weight. Like what I said earlier, the correct or the proper unit for mass is kilogram. But in this problem, the given unit is grams. So we need to convert grams into kilogram. How? Simply 5,500 gram in 1 gram. How many kilogram? There's 0.001 kilogram. So before you proceed, cancel the same unit. Gram. Okay. We already canceled the same unit, grams. Or simply multiply 5,500 times 0.001 kilogram and then divided by 1. The final answer is 5.5 kilogram. Okay, next. Formula. Weight is equals to mass times gravity. So, after we convert grams into kilogram, we have now the given 5.5 kilogram for mass. Simply multiply 5.5 kilogram to 9.8 meter per second. And the answer is 53.9 kilogram meter per second squared. Okay. Next, Last example, if the science book weighs 19.6 kilogram meter per second squared and mass is 1.2 kilogram on planet Venus, what is the strength of gravity of Venus? Okay, so we are looking for what? We are looking for the gravity on Venus. First, we need to write the given. The given weight is 19.6 kilogram and the given mass is 1.2 kilogram. The question is, what is the gravity on Venus? Okay, the formula that we are going to use is gravity equals to weight divided by mass. Okay, that's the given, the formula, and our solution. Simply, gravity equals to 19.6 kilogram meter per second squared and 1.2 kilogram. So after we substitute our given, we need to cancel the same unit. What is the same unit? Kilogram, kilogram. Simply 19.6 meter per second squared divided by 1.2, we will get 16.33 meter per second squared, and that is the gravity on planet Venus when you are lifting a science book about 1.2 kilogram with weight of 19.6 kilogram meter per second squared. Okay. Question. I know that you have a lot of questions about our discussion for today. If you have any question, you can send your question to my personal FB account and Gmail account, Cezar at 00@gmail.com. So that's my Facebook account and Gmail account, same email address and Gmail address. Okay, so let us answer this question. When do we do work? Other than people, who or what else can do work? For you class, let's answer this question. When do you do work? Or when do we do work? And other than people, who or what else can do work? Number one. Okay, you have your answer. Okay. If you want to share your answer in these two questions, you can send it also to my personal account, in my Gmail account and to my Facebook account. Okay, when do we do work? We do work when we are performing any activities or tasks in order to move. For example, you are pushing a cart. When you are biking, okay, that's the time that you do work. Other than people, who or what else can do work? Not only humans or people can do work, because there's a given object that can do work. Excuse po. For example, examples of objects that can do work. For example, ball rolling. What else? Um, um, Playing kite. What else? Any objects? Think of object that can do work. What else? For example, laptop under the table, even though there's a movement, still it can do work. That's what we call kinetic energy. Okay. If you have a lot of questions, please email to my account. Activity. Okay, I will be giving you activity for today. Number one, perform any activities that demonstrate kinetic energy and potential energy. Two examples each. Discuss the following activities on how to conserve mechanical energy. So your answer will be sent in my Gmail account and Facebook account, crucesar00 at gmail.com. Okay, I will wait for your answer and feedback. Okay, quiz time. Okay, please get your notebook or scratch paper. We are going to answer this question. Sample problem. crucesar00 at gmail.com. Again, if you have more questions about our discussion for today, please email me. So, for our quiz for today, here's the question. If Heidiline Diaz lifts 20-kilogram barbell above his head, a total distance of 2.5 meter, how much work does Hunter do on the barbell? How much work is done by gravity on the barbell? Okay, please answer this question and you can email your final answer on my Facebook account and my Gmail account. Okay, crucesar00 at gmail.com. Okay, and I will check your work if that's correct. Okay. Thank you for listening. God bless and stay safe. I know that you've learned something in our discussion today. And while we are waiting,